Hello, welcome to this lesson on entropy. Today's question of the day, why is it so hard to keep your room clean? We have this term in science called entropy, and it is the measure of disorder, randomness, or chaos in a system. So a concert would have more entropy than a library. For example, concerts, people do have assigned seats, but it's very loud. There's lights flashing everywhere. Everybody's screaming and making noise. It's really crazy. But a library, on the other hand, every book has a place, and we have a whole coordinate system to find books called the Dewey Decimal System. I had to learn it in elementary school. I don't know if they still teach that. So you have the Dewey Decimal System that puts all of the books on a particular place on the shelf so that they're easy to find. It's very calm and quiet in a library. A concert has far more entropy than a library does. Different samples will have different amounts of energy based on a few different characteristics or properties. So depending on the phase of matter, whether your compound or rather element, whether your substance is a solid, liquid, or a gas will count, or whether you're looking at an aqueous mixture. An aqueous mixture kind of fits in there. So solids are going to have the least amount of entropy because they're very organized, kind of like you can tell this is supposed to be an oval and this is a crazy scribble. Solids have a decent amount of, they don't have a lot of entropy because they have a decent amount of organization. You'll have one particle next to another, very organized, easy to predict. Gases, those particles are flying around all over the place, so they have quite a bit of entropy. A lower temperature is going to not have that much entropy, and that's because your particles move pretty slow, but the hotter it gets, the higher the temperature, the more crazy these particles are moving around. If you have fewer moles of a substance compared to more moles of that substance, more is more. Anytime we're talking about having a lot of stuff, we're also going to have a lot of entropy. It's hard to keep a lot of stuff organized. Last up is concentration, kind of related to moles. It's just also important to note that moles and molarity are not necessarily the same thing. They kind of communicate the same idea, but they're not the same thing. So this number of moles could just be moles of gas in a reaction chamber. It could be moles of substance, like a solid substance in your hand. Concentration can be changed by two factors. It can be changed by the amount of stuff dissolved or by the amount of water. So I like to keep those two ideas separate. The lower the concentration, the less entropy you have because your sample is like not so crazy. But the more stuff you have, the higher the concentration, the more crazy, chaotic, and disordered your system is going to be. Getting back to that question of the day, nature, I like to describe, is messy and lazy. So nature is always going to favor reactions that result in low energy and high entropy. So lazy is going to tag with the low energy. Nature does not really like to do stuff the same way you don't like to clean your room. And nature just appreciates chaos. It's just kind of the way that it is. It keeps life interesting. So that is where nature is going to be messy. Nature is not super organized. I mean, even if you go and look at like any plant, really, the root systems are kind of wild and crazy all over the place. The branches of a tree are wiggly and they kind of weave in and out of each other. It's not organized. It's not like straight on a coordinate grid coming in at specific angles. All of this stuff there's beauty in the high entropy that we have. So it's not that being messy and lazy is a bad thing. It's just how I describe nature to help me remember that we have a low energy, high entropy form of nature. But it's also important to remember that you are a part of nature. It doesn't feel that way a lot of the time, especially when you're sitting here watching a video on a YouTube channel. You don't consider yourself really a part of nature. But you are from nature, and this is why it's hard to keep your room clean, because I would say 999 out of 1,000 people would prefer to sit and watch Netflix than go run a marathon. And that's just because we're part of nature. We're kind of lazy. How many of us struggle to keep our rooms clean? I mean, I'm not scrubbing my bathroom mirror every day trying to keep off my little toothpaste flecks. I mean, I do. Not every day, though. And that's because we're messy. We don't like to clean up everything. We know that things have a place, but we don't necessarily work to put them there because we're a part of nature. And this helps us to explain why nature favors exothermic reactions. So any reaction that is going to result in the products having less energy than the reactants is favored by nature. It has a much smaller activation energy in order for that to happen. Those reactions are exothermic. Getting deeper into thermodynamics, there are equations that take into account whether a reaction is endo or exothermic and the amount of entropy change as we go from reactants to products. And you wind up with, it's called Gibbs free energy. I'm not going to talk about that here because I find that it's a pretty complex thermodynamics equation. But those two things are going to come hand in hand. Whether the reaction is endo or exothermic and how much entropy is being gained or lost during a chemical reaction, those two things together are going to determine the overall favorability of a reaction, meaning how difficult it is for this reaction to happen. But for your purposes in just level 1 high school chemistry, it's important to know that exothermic reactions are really going to take the cake here. In that big equation, temperature also plays a role. So it is possible that an exothermic reaction is not favored, but I'll tell you, it's pretty rare. It's the same thing with an endothermic reaction. It is possible for an endothermic reaction to be favored, but again, it's pretty rare. It's going to depend on the entropy and the temperature at which this particular reaction is going to happen. But blanket statement, exothermic is favorable because that is the low energy result. Obviously, our products have less energy than the reactants, and this much energy, the delta H, is released. Nature loves to release energy. Get it out. That is all I have for you on entropy. If there are any questions, please leave them in the comment section below the video. Subscribe so you don't miss the next lesson, and I will see you there. Bye.